In this video, we will talk about mathematical expectation, in which we will study how to obtain expected value of a random variable x under given conditions. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Suppose two fair coins are tossed simultaneously. Sample space S will be HH, HT, TH and TT. Number of sample points in sample space NS is 4. Let random variable x is number of heads obtained in a single toss. Two heads are occurring one time, so here x1 is 2 and its probability p1 is this 1 upon 4. One head is occurring two times, so x2 is 1 and the probability p2 is this 2 upon 4. Zero heads or no head is occurring one time, so x3 is 0 and its probability p3 is this 1 upon 4. Now the sum of products of probabilities pi and xi, where I runs from 1 to 3, is p1x1 plus p2x2 plus p3x3 equals 1 upon 4 into 2 plus 2 upon 4, that is 1 upon 2 into 1 plus 1 upon 4 into 0. 2 ones are 2 twos are, which gives this half plus this half equals 1. This is what we call mathematical expectation Ex, where this x is a discrete random variable and it is 1 in this case, which means when two fair coins are tossed simultaneously many times, then we are expected to get one head on the top on the average. If x is a discrete random variable which assumes values x1, x2, x3, etc., xn with corresponding probabilities p1, p2, p3, etc., pn respectively, then the mathematical expectation of x, which is denoted by E of x, is p1x1 plus p2x2 plus so on and so forth plus pnxn, or E of x summation pi xi, where summation pi, that is sum of probabilities, is 1. And if x is a continuous random variable with probability density function fx, then the mathematical expectation of x is E of x equals integral x into fx dx from minus infinity to plus infinity, where integral fx dx from minus infinity to plus infinity is 1. A fair coin is tossed 3 times. If a person receives rupees x, if he gets x heads, and receives rupees x square, if he gets x heads, we have to find how much he is expected to get in both the cases. That is, we have to find his expectation ex and ex square. When the fair coin is tossed 3 times, the sample space will be, first we write probability distribution of x. X for no heads or 0 heads, 1 head, 2 heads and 3 heads. Number of sample points ns is 8. Probability of x when he gets 0 heads is 1 upon 8. For one head we have 3 elements HTT, THT and TTH. So its probability will be 3 upon 8. Probability when he gets two heads will be 3 elements HHT, HTH and THH. So the probability of two heads will be 3 upon 8, and X with 3 heads will correspond to this single element triple H. So its probability will be 1 upon 8. So in this case, the expectation EX will be summation PIXI, which is 1 upon 8 into 0 plus 3 upon 8 into 1 plus 3 upon 8 into 2 plus 1 upon 8 into 3, which is 0 plus 3 upon 8 plus 6 upon 8 plus 3 upon 8, which is 12 upon 8. So the expectation EX when he gets X rupees for X heads is rupees 3 upon 2 or rupees 1 and half. In order to find EX square, we will prepare probability distribution of X square. X square is 0 square 0, 1 square 1, 2 square 4, 3 square 9. Probabilities of X will be same as above. 3 upon 8, 3 upon 8 and 1 upon 8. Expectation EX square will be summation PIXI, which is 1 upon 8 into 0, 0 plus 3 upon 8 into 1 plus 3 upon 8 into 4 plus 1 upon 8 into 9, which is 3 upon 8 plus 12 upon 8 plus 9 upon 8, 24 upon 8, which is 3. So the expectation EX square when the person receives rupees X square when he gets X heads is rupees 3. So this is his expectation. In the next problem, it is given that a fair coin is tossed till a head is obtained. We have to find what is the expectation of the number of tosses, which means what are average number of tosses required till a head appears. Let X be the order of toss for which we get a head, and these events will be and the corresponding number of toss. In the first toss, head appears. In the second, head appears after a tail. In the third, head appears after 2 tails. In the fourth, head appears after 3 tails, so and so forth. And for X, fifth toss, sixth toss, etc. Probability of X for X when the first toss occurs will be 1 head out of 2 outcomes. For second toss it will be for this tail it is half into for this head it is half again, which is 1 by 4. For third toss, for first T it is half, for second T it is half into for this third H it is half again, so it will be 1 by 8. For fourth toss, for this first T probability is half into for the second T it is half, for third T it is half, and finally when H appears it is half again, which will be 1 upon 16, so and so forth for fifth, sixth number of tosses. So the expectation EX will be summation PIXI, which is this 1 into this half plus this 2 into this 1/4 plus this 3 into this 1 upon 8 plus this 4 into this 1 upon 16 plus so and so forth, which is half plus 2 into 1/4 plus 3 into 1 upon 8 plus 4 into 1 upon 16 plus so and so forth. For the calculation purpose, we will assume this to be S. Multiplying throughout by half, it will be half S equals half into half 1/4, but we write it as 1 into 1/4 plus 2 into half into 1/4 1 upon 8 plus 3 into half into 1/8 1 upon 16 plus 4 into half into 1 upon 16 1 upon 32 plus so on and so forth. Now we will subtract this half s from this s. Let us rewrite the statements of s and half s. Now this s minus half s will be, we will subtract the like terms. So this half minus 0 is half plus 2 times 1/4 minus 1 time 1/4 is 1/4 plus 3 times 1 upon 8 minus 2 times 1 upon 8 is 1 upon 8 plus 4 times 1 upon 16 minus 3 times 1 upon 16 is 1 upon 16 plus so on and so forth. Now s minus half s is half s equals 1 half plus 1 upon 4 plus 1 upon 8 plus 1 upon 16 plus so on and so forth equals, taking half common, it will be 1 plus 1 half plus 1 upon 4 plus 1 upon 8 plus so on and so forth, which is half into sum to infinity. Here first term a is 1 and common ratio r is this half upon 1 half. So this is half into sum to infinity is a upon 1 minus r, that is half into 1 upon 1 minus half, which is half into 1 upon half. Cancelling this half with this half, it will be 1. Since 1 upon 2s is 1, implies s equals 2, but s is expectation x, therefore expectation x is 2. So the expectation of the number of tosses required till a head appears is 2. Before we move on to the next problem, let us understand, if values of random variable x, x1, x2, x3, etc., xn are equiprobable, that is, if p1 equals p2 equals p3 equals so on and so forth equals pn, it will be 1 upon n, and in this case expectation x will be 1 upon n summation xi, which is a simple arithmetic mean of the n values x1, x2, x3, so on and so forth xn, which are equiprobable, that is, their probability is equal. In the next problem, a box contains n tickets numbered 1, 2, 3, etc. n. If m tickets are drawn from the box randomly, we have to find expectation of the sum of the numbers on the tickets drawn. We will start by assuming xi to denote number on the ith ticket drawn. So sum s will be x1 plus x2 plus x3 plus so on and so forth plus xm. Now we have expectation xi to be summation pi xi. Now here the numbers x1, x2, x3 are equiprobable, therefore this pi will be 1 upon n, therefore this will be 1 upon n summation xi, which is 1 upon n into 1 plus 2 plus 3 plus so on and so forth plus n, which is 1 upon n into sum of first n natural numbers is given by n into n plus 1 upon 2. After cancelling this n, we get n plus 1 upon 2. So expectation for this sum s will be summation of expectation xi, where I runs from 1 to m, will be m times expectation xi n plus 1 upon 2, which is m into n plus 1 upon 2. Next question. There are 3 urns. First urn contains 3 green and 2 white balls. Second contains 5 green and 6 white balls. Third contains 2 green and 4 white balls. One ball is drawn from each urn. We have to find the expected number of white balls drawn. Let X denotes number of white balls drawn from the urn. So expectation of X will be summation Pixi, which is P1x1 plus P2x2, because there are only two types of balls, green and white. Since one ball is drawn, X will be 1 if white ball is drawn, and X will be 0 if green ball is drawn, because we have to find expectation of white ball. Now let us find expectation from each urn. From first urn, expectation x1 is probability 2 upon 5, because there are two white balls and total number of balls is 5, multiplied by x1, which is this one, plus probability of getting green ball is 3 upon 5, multiplied by x2, which is 0. So this will be 2 upon 5. From second urn, expectation x2 will be probability p1 for 6 white balls will be 6 upon 11, because total number of balls in second urn is 11, multiplied by probability of drawing white ball is 1, plus probability of drawing green ball will be 5 upon 11, and x2 when green ball is drawn is 0. So this will be 6 upon 11, and from third urn, expectation x3 will be probability for 4 white balls will be 4 upon 6, because total number of balls in the third urn is 6, multiplied by probability of drawing white ball is 1, plus probability of drawing green ball is 2 upon 6, multiplied by x2 for drawing green ball is 0. So this is 4 upon 6, that is 2 upon 3. So the expected number of white balls drawn, that is Ex, will be sum of expectations from each urn, Ex1 plus Ex2 plus Ex3, that is 2 upon 5 plus 6 upon 11 plus 2 upon 3, that will be LCM of 5, 11, 3, 165. This 2 multiplied by 165 upon 5, 33, plus this 6 multiplied by 165 upon 11, 15, plus 2 multiplied by 165 upon 3, 55. This will be 66 plus 90 plus 110 upon 165, which is 266 upon 165, which is 1.61. So the expectation is 1.61, which means that on an average 1.61 white balls will be drawn from these three urns. In the next problem, it is given that daily consumption of electric power in million kilowatt hour is a random variable x with probability distribution function fx equals k x e raised to minus x upon 3 when x is positive, and it is 0 if x is non-positive. Here we have to find the value of this k, expectation of x, and the probability that on a given day electric consumption x is greater than the expected value Ex. First let us find the value of k. We have for probability distribution fx dx from minus infinity to plus infinity equals 1. In this case it will be k times 0 to infinity x e raised to minus x upon 3 dx equals 1, which is an equation in k. So this will be k into, we will solve this integration by parts, which will be first this x into integral of e raised to minus x upon 3, which is e raised to minus x upon 3 upon derivative of minus x upon 3, which is minus 1 upon 3, minus derivative of this x, which is 1, into integral of e raised to minus x upon 3 upon minus 1 upon 3, which will be minus 3 into integral of e raised to minus x upon 3 is e raised to minus x upon 3 upon derivative of minus x upon 3, which is minus 1 upon 3, and here ends integration by parts from 0 to infinity, which is equal to 1. This further will be k into e raised to minus infinity upon 3 will be 1 upon infinity 0 plus e raised to minus infinity upon 3 is once again 0 minus 0 into e raised to 0 upon minus 1 upon 3 will be 0 plus 3 into minus 3 e raised to 0 is 1 equals 1. That will be 9k equals 1, that is k equals 1 upon 9. Now this k is 1 upon 9. Let us find expectation Ex, which will be integral x fx dx from minus infinity to plus infinity, about which we have already discussed. That will be k, which is 1 upon 9 times integral x into this x e raised to minus x upon 3 dx from 0 to infinity, which is 1 upon 9 integral x square e raised to minus x upon 3 dx from 0 to infinity, which is 1 upon 9. We will solve this integral by parts. First, this x square into integral of e raised to minus x upon 3 e raised to minus x upon 3 upon derivative of minus x upon 3 minus 1 upon 3 minus derivative of x square 2x into this minus 3 into integral of e raised to minus x upon 3 e raised to minus x upon 3 upon derivative of minus x upon 3 minus 1 upon 3 plus minus 3 into minus 3 9 into derivative of 2x, which is 2, into integration of e raised to minus x upon 3 e raised to minus x upon 3 upon derivative of minus x upon 3 minus 1 upon 3 from 0 to infinity. This further will be 1 upon 9 into 1 upon e raised to infinity will be 0 plus 1 upon e raised to infinity will be 0 again plus 1 upon e raised to infinity is 0 minus 0 square is 0 minus 2 into 0 is 0 minus 9 2s are 18. 18 multiplied by 3 54 into e raised to 0 is 1. So this will be minus into minus plus 54 upon 9, that is 6. So the expectation of x is 6. In the next part we have to find probability when on a given day the electric consumption is more than the expected value, that is probability when x is greater than 6. Now probability when x is greater than 6 is 1 upon 9 integral x e raised to minus x upon 3 dx from 6 to infinity, which is 1 upon 9 integration by parts this x into integration of e raised to minus x upon 3 is e raised to minus x upon 3 upon derivative of minus x upon 3 minus 1 upon 3 minus this minus 3 into derivative of x 1 into integral of e raised to minus x upon 3 e raised to minus x upon 3 upon derivative of minus x upon 3 minus 1 upon 3 from 6 to infinity. This will be 1 upon 9. 1 upon e raised to infinity will be 0 minus 3 3s are 9 into 1 upon e raised to infinity will be 0 minus 6 into this minus 3 into e raised to minus 6 upon 3 e raised to minus 2 plus 9 into e raised to minus 6 upon 3 e raised to minus 2. This will be 1 upon 9 into 0 plus 18 plus 9 plus 27 e raised to minus 2. This will be 3 e raised to minus 2, which by calculator will be 0.406. So this is the probability when on a given day the electric consumption is more than the expected value 6, 0.406. In the next example, we have to find k and then expectation of x if x has following probability density function fx equals k into x into 2 minus x if 0 is less than or equal to x less than or equal to 2 where k is positive and fx is 0, otherwise integral fx dx from the domain 0 to 2 will be integral k into x into 2 minus x dx from 0 to 2, which should be 1. Therefore, k integral 0 to 2 of 2x minus x square dx equals 1. Therefore, k 2 x square upon 2 minus x cube upon 3 from 0 to 2 equals 1. K, this 2 cancels out. 2 square, which is 4, minus 2 cube 8 upon 3 minus 0 equals 1. So k into 4 upon 3 equals 1, which means k equals 3 upon 4. Now expectation x is integral from 0 to 2 x into k fx dx, which is k 3 upon 4 into x square into 2 minus x dx, which is 3 upon 4, 2 x cube upon 3 minus x raised to 4 upon 4 from 0 to 2, which is 3 upon 4, 2 upon 3 into 2 cube 8 minus 1 upon 4 into 2 raised to 4 16 minus 0, which is 3 upon 4 into 16 upon 3 minus 16 upon 4, which is 3 upon 4 into 16 into 1 upon 3 minus 1 upon 4. 4 ones are 4 fours are. So this expectation will be 12 into 4 minus 3 1 upon 12. 12 cancels and we get expectation of x to be 1. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.